slightly away, but when we do the experiment, we place it in contact with the chuck. Both the cylindrical masses at the closest distances are placed in contact with the chuck. So you can see from the axis of rotation up to the center of the mass, that distance is d1. And when you keep it at a farther distance, the distance between the axis of rotation and the center of the cylindrical mass is d2, and the length of the suspension wire is from the point of suspension to the point where it is affixed to the chuck near the inertia disk, that is L. Now let us see how we perform the experiment. First, take the wire given to you for measuring the length of the suspension wire, keep it like this at one end of the chuck, and then up to the point of suspension, find out what is the length. You have a scale, keep it on the scale from the left end of the scale, that is the 0, and up to what point you have measured it. Note down the length in the column provided in the tabulation in your manual. The next thing you have to do is measure the diameter of the wire, and hence you can find radius. So for that you are provided with a screw gauge. The operation of the screw gauge is already mentioned to you. First note the zero error and zero correction of the screw gauge. Then keep the wire in between the two surfaces of the screw gauge. Do not overturn the screw gauge, because if you start turning it too much and show all your power on it, the wire will start compressing and you will not find the correct diameter of the wire. So you have to stop the rotation of the arm of the screw gauge when you feel the surface of the wire. At that time, note the pitch scale reading and also the head scale coincidence. Now here there is a common mistake which everybody does. Generally the pitch scale 1 is slightly visible, so people write the pitch scale reading as 1 instead of 0. This is a common mistake which is also committed when we actually read time in our wall clock. That is, the time may be 2:59. That is, it is nearly 3 o'clock, but people often make the mistake of telling that as 3:59 because our hand has crossed the 2 marks slightly, but that is not correct. It is actually 2:59 or nearly 3 o'clock and not 3:59. Similarly, here also the pitch scale reading will be only 0 and not 1. In case you have a doubt, you can approach the concerned staff member and verify. So please do the diameter of the wire first before starting the experiment. Verify whether the screw gauge reading is correct. Only then proceed with the experiment. You have to take the reading at 2-3 places which are slightly farther away from each other and record it in the respective tabulation given to you already in the manual. So since you have found the diameter, half that value will give the radius, and you can convert it to meters and keep it aside. Now you are ready to start the actual experiment. So what we have done, we have found out the length and we have found out also the radius of the wire. Now our business is to find out the time period of oscillation without masses, with masses at closest distance and with masses at farthest distance. So we have to find out T0, T1 and T2. That is time for one oscillation. So just by taking one oscillation, accuracy will not be there. So we have to take time for 10 oscillations, then convert it to time for one oscillation. For finding out time for 10 oscillations, we first make a mark on the inertia disc for reference like this. It is already marked sometimes, but if it is not marked, use a marker pen and make a mark like this, so that it is very clearly visible to you. Then verify the stopwatch that is given to you if it is working properly. Do not start the experiment without verifying the stopwatch, otherwise it will be a waste in the middle to stop. So how do you verify? See, this is a razor stopwatch in which you have minutes, seconds, and then 0.00 seconds. That means you can read the time up to 1/100th of a second. So you have to record all the divisions on the stopwatch whenever you do the experiment. Do not round off any division. So how do you check the stopwatch? See whether you press the mode and see whether it is in the stopwatch mode, and then to start the stopwatch, press start stop and see whether it is running properly. So again stop it. If when you press the stop button, the watch must stop playing, and then you have to bring it back to 0. So at that time press the reset button, that is on the left hand side of what I am showing, left hand side of the instrument of the watch. So once you have confirmed that the stopwatch is working properly, go to torsion pendulum for recording oscillations. So you can see that I am now slowly placing my fingers on the chuck and giving a small rotation. The torsion pendulum, the inertia disc should not wobble like this, nor should it oscillate like this so fast. It shouldn't go like this. If it is going like this, it is wrong. The whole experiment will be wrong, because your formula holds good only for small oscillations, because you know the angle of rotation theta will be equal to sine of theta only for small oscillations. So to correlate experiment and the formula, you should oscillate the pendulum very slowly. So that means the angle of rotation should be very, very small. That means around 30 degrees only. So that is what I have done now. You can see I have stopped the wobbling and I am allowing it to rotate very, very slowly. You can see it is a very small oscillation. You can see this mark, it is going from there to maximum. This place you can see the oscillation is very small. Do not start taking readings now. Allow the torsion pendulum or the inertia disc to oscillate for some time. Let it attain freeness. After that, we have to start taking the time for 10 oscillations. That is why we have taken the reference. Now what is one oscillation here? How will you count one oscillation? So let us say this is the reference I have taken. So let it come back to the position nearby me. I will start that as my starting point. You can see here now this is the starting point, this is 0. I start the stop clock here, this is 0. It goes there and then comes back to the same point. This will be one oscillation. And it goes back, again comes to the same point, second oscillation. Like this, we have to count 10 oscillations. So what is one oscillation? I will repeat. I start here, I go there, and then come back to the same point. That is, you start your relay race, just like your relay race. You start the relay race at one point and you come back to the same point. So start, go to the ending point, another place, then come back to the same point. That would be one oscillation. So count 10 oscillations like this, and then that is going to be the trial number 1. Now for trial number 2, do not stop the torsion pendulum. Stop only the stopwatch, because this will keep going on. Do not again and again start and stop the torsion pendulum for 2 trials. Now let us see how you actually record the time. So now we will start. This is the turning point. I've started. This is 0. It goes to the other point. You can see the oscillation is very small. Now it comes back here. This is 1. Two. 3. 4. 5. 6. 7. 8. 9. 10. So you stop the stop clock, stopwatch. Do not stop the inertial disc. So another precaution is, very often we have seen people simply stand near the torsion pendulum and it oscillates. They start the stop clock correctly, but their eye is not held to the reference point. They simply don't bother. They keep the stop clock here. They see somewhere here and there. So they would have missed out on oscillation. So finally all the